Good afternoon. I am Dr. Dinabandhu Manna. I am Assistant Professor in Department of Chemistry, Swami Vivekananda Institute of Science and Technology. Today I want to discuss a few topics in thermodynamics. Now, mainly constant volume process, that is isobaric process, constant pressure process, that is isobaric process, and isothermal process, that is temperature constant. Okay. Now, from first law of thermodynamics, we have dq is equal to du plus dw. Okay. Now, in previous class, I have proved that dw we can write as pdv. Okay. So, if we replace this pdv in the equation, then the equation becomes dq is equal to du plus pdv. Okay, right? Now, this is for constant volume process. Constant volume process. Okay. So, what happened? For constant volume process, that is isobaric process, V equal to constant. V equal to constant. So, if we do derivative of the constant is 0, so the equation becomes delta Q is equal to du plus pdv, that means this is equal to 0. Okay. So, this becomes dq is equal to du. Okay. So, this is for constant volume process. Now, we know that delta Q is equal to delta T AB at constant volume is equal to du by dt at constant V. So, therefore, we can write as delta Q is equal to Cv dt, or that is equal to delta U also. So, this is for constant volume process, where Cv is the specific heat at constant volume. Okay. Now, if the pressure is constant, that is for P equal to constant, that is called isobaric process. Okay. Now, we know that H, this is enthalpy is equal to U plus PV. Okay. Now, if we take derivative in both sides, that is PV. Okay. Now, again, dH is equal to du plus pdv plus ddv. Okay. Now, for constant pressure process, again delta P equal to 0. So, we can eliminate this term. Okay. This is equal to 0. So, the equation becomes delta H is equal to du plus pdv, that is equal to also delta P. Okay. So, from there we can write the dq is equal to du plus pdv. Okay. From there we can write that so dq equal to cp dt is equal to dh for isobaric process. Okay. And final term is that is for T equal to constant. Okay. This is called isothermal process. Okay. Isothermal process. So, what happened in isothermal process? So, we know that delta Q equal to du plus dw. Okay. Now, dq equal to du plus pdv. We assume that internal energy U is a function of temperature. Okay. U is a function of temperature. Assuming that. Okay. Assuming that U is a function of temperature. So, if the temperature is constant, okay, so delta U equal to 0 become. Okay. So, if delta U equal to 0, so what happened? Then delta Q is equal to pdv. Now, if we assume that ideal gas PV is equal to nRT, and for 1 mole gas N is equal to 1, what happened? PV is equal to RT. Now we replace PV, we replace P in this equation, so that this is equal to RT by V into dV, delta Q is equal to. Now we integrate this equation. So delta Q equal to so from V1 to V2. Now R is universal gas constant and T also constant for isothermal process. So we can simplify this equation by delta V by V. So this is equal to RT and this become ln V from V1 to V2. Okay. Now this term equal to upper limit minus lower limit. So if log upper limit by lower limit, that means this is divided. Okay. And we all know that this V is inversely proportional to 1 by P. So from there we can also write this P1 by P2. Okay. So delta Q equal to, so these two are the formula for isothermal process. Okay. And one important question for mark out has been come, that is Cp minus Cv is equal to R. Now previously we proved that what happens, H is equal to, you know that U plus Pv. Okay. So dH equal to du plus dPv. Okay. Now we know that Pv is equal to RT for n is equal to 1. Now if we replace this, dH is equal to, this is dRT. Okay. Now again dH equal to du plus, as R equal to constant. Okay. So delta T. Now if we divide by delta T both side equation, so dH equal to dt is equal to du plus R. Okay. So we know that this is equal to Cp and this is equal to Cv, as we know that dH is equal to Cp dt and du equal to Cv dt. Okay. So from there we can write Cp is equal to Cv plus R. Okay. And from there Cp minus Cv equal to R. Okay. So this is from the derivation of the first law, and in the next video I will discuss about the second law of thermodynamics.